Good morning, students. Today, let us see about transactions and its properties. So, the term transaction refers to a collection of operations that form a single logical unit of work. A transaction is a unit of program execution that accesses and possibly updates various data items. For example, transfer of money from one account to another is a transaction consisting of two updates, one to each account. A transaction is delimited by statements or function calls of the form being transaction and end transaction. The transaction consists of all operations executed between the begin transaction and the end transaction. Let us see a simple transaction model. Transactions access data using two operations. Readx, writex. Readx, database to main memory buffer. Transfers the data item X from the database to a variable X in the main memory buffer of the transaction that executed the read operation. Write of X, main memory buffer to database. Transfers the value in the variable X in the main memory buffer of the transaction that executed the write to the data item X in the database. Let TA be a transaction that transfers $50 from account A to account B. This transaction can be defined as TI read A. Now we are reducing the value of A by 50. Then I am going to write. If suppose A is 100, now the value will be 50. Now I am going to read B. If suppose value of B is 200, to that 200 I add 50. Now I get 250. Now next I write the content of B. Okay, now next let us see the transaction properties, ASP properties. A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. Atomicity. Either all operations of the transactions are reflected properly in the database or none are. Assume that before the execution of the transaction TI, the values of accounts A and B are $1000 and 2000. Now suppose that during the execution of the transaction TI, a failure happened after write A operation but before the write B operation. In this case, the values of accounts A and B reflected in the database are 950 and 2000. The system destroyed 50 as a result of this failure. The sum of A plus B before and after the execution of the transaction is not same and the database is now in an inconsistent state. We must ensure that such inconsistencies are not visible in a database system. The basic idea behind ensuring atomicity is the database system keeps track of the old values of any data on which a transaction performs a write. This information is written to a file called the log. If the transaction does not complete its execution, the database system restores the old values from the log to make it appear as though the transaction never executed. So, to ensure atomicity, it is the responsibility of the recovery system of the database. Second important feature is consistency. The consistency requirement here is that the sum of A and B be unchanged by the execution of the transaction. Without the consistency requirement, money could be created or destroyed by the transaction. The consistency requirement verifies that if the database is consistent before an execution of the transaction, the database remains consistent after the execution of the transaction. So ensuring consistency for an individual transaction is the responsibility of the programmer who codes the transaction. Isolation. If several transactions are executed concurrently, their operations may interleave in some undesirable way, resulting in an inconsistent state. For example, if the database is temporarily inconsistent with the deducted total returned to A and increased total to be returned to B, right? If a second concurrently running transaction reads A and B at this intermediate point and computes A plus B, it will observe that the inconsistent value because it is wrong. A way to avoid the problem of concurrently executing transaction is to execute the transaction serially. So if you find that there is dependency, we cannot execute the transaction simultaneously. We are supposed to do one after the other in the sequence. Concurrent execution of transaction provides significant performance benefits such as improved throughput and resource utilization and reduced waiting time. The isolation property of a transaction ensures that the concurrent execution of a transaction results in a state that is equivalent to a state that could have been obtained when the transactions are executed on one at a time in some order. Ensuring isolation property is the responsibility of the concurrency control component of the database system. Durability. The durability property guarantees that once a transaction completes successfully, all the updates on the database persist, even if there is a system failure after the transaction completes execution. We assume for now that a failure of a computer system may result in loss of data in memory, but data written on disk are never lost. Durability is guaranteed by ensuring that either the transaction updates have been returned to a disk before the transaction completes. Information about the transaction updates and the data returned to disk is sufficient to enable the database to reconstruct the updates when the database system is restarted after the failure. Ensuring durability is the responsibility of the recovery system of the database. Thank you, students.